You are welcome once again to our maths and physics class. We are here again to still work on more examples under INDICAL equations. We did about 2 last time, so today let us also look at 2 examples that we can solve. At that last time, we were able to solve some simple equations and we were able to get values of unknown that were involved in the equation. So today, let us go with the first one. The first one that we have here is 4 raised to power n. 4 raised to power n equals 32. Like I told you last time, when you have INDICAL equations, the first thing that will come into your mind is how can I express both the left hand side and the right hand side to have the same foundation numbers. Here on the left hand side we have 4 foundation number, here we have 32. Is there a way that we can express 32 to have 4 as foundation number? No. Because if you say 4 raised to power 2, which is the simplest one, is 16. 16 times 4, we are going to be having 64. So we are not talking about 64 here, we are talking about 32. So, is there a way that we can express 4 in another foundation number and I express 32 in another foundation number, and these foundation number are the same? Yes, is the answer. What number is that? 2 is a common foundation number between 4 and 32. How? 4 is the same thing as 2 raised to power 2. 4 is the same thing as 2 raised to power 2. From my explanation on our former video, we said that 2 raised to power 2 means 2 times 2, which is 4. That is the 4 that is there. Okay, what about the n, that is the power? Is still there, we'll bring it down. So you see that 4 raised to power n is the same thing as 2 raised to power 2, all bracket n. We have expressed the left hand side. So let us go to the right hand side. The right hand side we have 32. 32 can be expressed in 2 as foundation number. And 2 raised to power 5 is equal to 32. How? If you multiply 2 into 5 places, you get 32. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. And 16 times 2, 35. So it means that 32 is the same thing as 2 raised to power 5. So you see that this, the left hand side is having 2 as foundation number, and the right hand side is also having 2 as foundation number. So let us go further with the expression. We are moving down. Do you remember when we talked about one of the laws of indices, where we said that we have powers of powers? That is the law of powers. Now 2 raised to power 2 and all raised to another power n. That law says that once a number or unknown is raised to double powers, what do we do to the powers? We multiply them. So in this case, we are going to be having 2 raised to power 2 times m, 2m. That is what we concluded in that law. So the left hand side is done. So we move on to the right hand side. We'll just bring that one down, 2 raised to power 5. So if we are having the same foundation number 2, 2 equal, it means that their powers are also equal. So in this case, we say therefore 2m is equal to 5. If 2 is equal to 2, then it means that 2m is also equal to 5. That is what we are saying from the law. Then, if we have this expression, what do we do? 2m is equal to 5. You divide both sides by 2. Because the coefficient of m here is 2. So if I want to remove this 2, I have to divide this left hand side with 2. If I divide the left hand side with 2, I must also divide the right hand side with 2 to make the equation balanced and equal. Take note of this, that when you are having an equation, whatever you do to the right hand side, you must also do the same to the left hand side. And for me to cancel these 2 so that m will be alone, standing alone, because it is m we are looking for the value, I must divide this side with 2. And if I do that, I must also divide the other side by 2. So in that case, I will say 2m divided by 2 is equal to 5 divided by 2. When I have this like this, these 2 can cancel this, leaving m alone. M is equal to 5 all over 2. If I want to express this one in mixed numbers, I can say 2 whole number 1 over 2 is the value of m. So what we have just done is trying to look for the value of m when you have 4 raised to the power m is equal to 32. And expressing them in another form, we have 4 as 2 raised to the power 2. This m is down. Then we have 32, which is also 2 raised to the power 5. If the two base numbers are the same, then the powers are the same. So that makes 2m equals to 5. And for me to allow m to stay alone, I will have to divide this side by 2. Whatever I do to the left hand side, I will do the same to the right hand side. If I divide 5 by 2, which is the value of m now, I can express that in mixed number where I will have 2 whole number 1 over 2. So let us look at the second example. The second example do not have straight line expressions. The left hand side is a straight line expression, but the right hand side is a fraction. How do we handle such? There are two ways you can do this. It is either you change this one to a straight line number, or you change the 27 to C, if you can express it as a number that is having 3 as the base or 3 as the foundation number. In whatever way you approach it, you still have the same answer. You are going to have the same answer, the same value for m. So let us look at the left hand side. The left hand side, we can just bring it down as having the same value, equal to. Then what about the right hand side? Can we express 27 to have the same foundation number as 3? Yes. I can then say 1 all over 27 is the same thing as 3 raised to the power 3. 27 is the same thing as 3 raised to the power 3. So you can see that we have the left hand side having foundation number 3, and the right hand side is also having foundation number 3. That will remind us of the negative reciprocals or the negative indices that we talked about, that we also refer to as reciprocals. So can I make this a straight line expression just like the left hand side? Yes. We said in that law that for you to have 3 raised to the power 3 as denominator of a fraction, it means you have moved it from the numerator down. It will change to positive, meaning it was negative before. Because it is only negative that will bring in 1 all over. So for me to have this expression, it will be the same thing as saying 3 raised to the power minus 3. You see that the 1 all over has moved. What has replaced it? The negative of the power. So we bring down the left hand side. Like I said before, if you see this, you remember when we dealt with negative indices, which is reciprocal. If I want to express this one in another form, I will just say 1 all over. Because of this negative power, 1 all over. That negative will go, then I will only bring in 3 raised to the power 3 as positive as the denominator. But we are like going back from this expression down to this side. So you can now see that the expression or the equation is now having the same foundation number. We have 3 as the foundation number on the left hand side of the equation, and we have 3 on the right hand side of the equation as foundation number. So if they are the same, they are equal, it means that the powers are also equal. So in this case, we can now say, therefore, m, which is the power on the left hand side, is equal to minus 3, which is the power on the right hand side. The most important part of this second example is for you to know how to convert and manipulate the expression that we have on the right hand side. It's a fraction, but I can change this fraction to be a straight line expression. I can as well change this 27 instead of raised to the power 1. Once it becomes a straight line, or I take it up, it becomes 27 raised to the power minus 1. If I do it the same, it will still result to 3 raised to the power minus 3. So 1 over 27 is the same as 1 over 3 raised to the power 3, and we have explained why 3 raised to the power 3 is 27. The left hand side is 3 raised to the power m. This is a fraction. A fractional index is a reciprocal. Once you move this to a straight line, the positive becomes negative. There will be no 1 all over again. Once the foundation number are equal, then I can pick the powers to be equal as well. So that is what makes m equals to minus 3. If you fix minus 3 in this place, you find out that the left hand side and the right hand side, they will be equal. So that is how we're going to end today's worked examples on INDICAL equations. Please like and comment on this page and under this video. Share. It is very important for you to share these videos so that others will benefit just the way you are benefiting. And it's another way of encouraging us to do more of these videos. And as well, you will also be part of those that will receive any video once we upload them in this page. Thank you for watching.